Determine concavity of all solutions in quadrant 2. So that shouldn't have been too bad. So your second derivative should have been simplified down to 4x squared y to the 7th plus y to the 4th. I will be getting you something, yes, Ms. Bergen.
I wouldn't call that off topic.
Yeah. Well, it's not on this, is what she's saying. But yeah, no, I'll have something for you. You know I will. Again, check your second derivative. 4x squared y to the 7th plus y to the 4th. And then since you're in quadrant 2, we know that the x's are negative and the y's are positive. So if x's are negative and y's are positive, since x is squared, and you're adding two things together, it's going to be positive, so it'll be concave up, since the second derivative is positive. You do need to mention something about the fact that it's positive because the, well, I guess I didn't even make you say y exactly, but you need to mention the fact that x is negative, y is positive, therefore the second derivative is greater than 0, therefore concave up in some way, fashion, or form. You can write it out however you would like to do. Questions about that one? Okay, taking my silence as a no. Let's see, find the particular solution to the differential equation with the initial condition of that. Okay, that's not too bad. It's a separation of variables. Do I need to work that one out for people? Or just give the answer? God, that's an ugly answer. Okay, so no response. I'm going to give the answer. So it should be the cube root of 2 divided by the quantity 46 minus 3x squared.
The quantity of.
Yes, that is the proper way to read it. Now, with that being said, do I need to work out the differential equation, or do we think we got that one?
I didn't get that.
What did you get?
I got negative 25 thirds.
Are you talking about for your C value?
Yeah.
Okay, C, that was the solution to the differential equation. The C value is something you need to get the solution. You then have to solve for Y. Remember, I told you guys, we've talked about this before a lot. Whenever you solve a differential equation, your answer is Y equals blah. So you have to solve for your C value, which is definitely a step you need to do, and they're saying the answer is negative 23 thirds. After you get the negative 23 thirds, and again, if you need me to work it out, I can work it out real fast, it's not a big deal. You plug that back into your C value and then solve for Y algebraically.
Oh, yeah, wait, what was the answer?
Cube root of 2 divided by 46 minus 3x squared.
Okay. Alright, I see now.
Do you need me to work anything?
No.
Okay. Anybody else need me to
Thanks.
work anything? Okay. Take that as a no. Okay, then moving on to part B real fast then. Okay, limits. So the answer should be 6 and 0, I think. Yep. You guys probably did not know how to do those too. It's a logistic question. I'll get you the formula for logistic, but this is a straight up logistic formula question. So basically it's the carrying capacity equation, if you've ever heard of that in your biology classes, if you've done biology or anything like that. I'll just get you the format equation now, but basically it's a kind of an inverse logarithmic curve where it starts off growing very fast and then tapers off to zero basically, where the carrying capacity is the maximum. So it's like if it's a population question, for instance, so it's always the whole idea, in which ironically suits very well for the time we're in right now, how many people can get sick type question. So like if one person gets it, they transfer it to another person, then someone else transfers it to two people, and then two people, and then two people, etc. The difference between exponential growth and logistic growth like this is that it can only grow so high because there's only a certain amount of population, in other words. So in this case, let's see, liquid for this one doesn't really have those easily understandable restraints. But you can only put so much liquid into the soil basically before it's just water. So you can only put in there. That's where it comes from. But usually they do with like logistic is a lot of times done with population and things like that, to where it's a clearer idea. Like you can't have more people sick than there is population. That should hopefully make sense. So it's a flattened curve, in other words, is what they want to do, but it just stays flat to where that many people are sick and things like that. But if you look in the equation, the f on the inside of the parentheses, that can't go more than 6 because you can't have a negative rate of adding in. And the slope goes to 0 basically, so yeah. Part B again is a formula that you just don't know. It's at half that value, so it's at 3. 1 f is equal to 3. Like I said, I'll get you the information on this one, so don't worry about this one. You should have been able to find the second derivative, though. That should be easy. So part C, your second derivative, should be 2/9 f times f minus 6 times f minus 3 is what they factored it out to. I actually substitute your first derivative. So that shouldn't have been too bad, the second derivative part, because that's pretty straightforward. It's just a product rule. And part D, Euler's method. Shouldn't be too bad. We did Euler's method the other day. Your answer you should have gotten for part I, because apparently it's a 2-part question. So I should have been 45/8. And then double I. The answer is overestimate because it's concave down. Getting old. Okay, so a lot of silence. So I'm assuming everybody's okay. Okay then. Moving on to Unit 8 then. Number 1. What is the average value? How do we find the average value?
Integral divided by the bounds-ish. Track each other.
Yeah, basically. So integral from a to b divided by b minus a. So it's basically your slope equation with an integral. It's capital F of B minus capital F of A over B minus A. So that shouldn't have been too bad. The answer to number 1 is B.
So you have to find the integral yourself, obviously.
Oh,
You
no,
do.
no. You would not be able to find the integral of that.
Oh, so you can just put in the bounds and then put that in?
Yeah, it's a calculator. Math 9, 2 to 6.
Oh, okay.
Yeah, anytime you see calculator with an integral, never do it by hand. Ever. That, I don't know if that's something you can even actually find the antiderivative of without some extraordinary means. Yeah, I don't know if I'd be able to, off the top of my head, be able to find the integral of that, to be honest. Part B. How do you find the net change in velocity?
I just use the same formula.
That would not be correct. That would be the average. Technically, that would be... You found the average acceleration is what you found if you use the same formula as number 1. Remember, integral is the net change. So it's just the integral of acceleration is the net change in velocity. So you're just literally doing the integral of a of t from 0.75 to 2.25. So you have to remember that when you do the definite integral from a to b, like for this kind of stuff, so the integral of acceleration is velocity, so the antiderivative is. So if you do the integral of acceleration, you're finding velocity of b minus velocity of a, which is what we call your change in velocity, your delta velocity. They're calling it the net change, which is perfectly fine. So integral from a to b of a of t is equal to b of b minus b of a, which is equal to delta v. So we can't forget that's what an integral actually means. You're finding the change in the antiderivative. So if I do the integral of velocity, or acceleration, sorry, I'm going to get my velocity function. We know that because the antiderivative of acceleration is velocity. But if I'm plugging in b and a, I'm doing v of b minus v of a, and that is what we call delta. Remember, final minus initial from when we talked about all the acceleration stuff. So that is how you find the change in. And again, do not attempt to do this by hand. Hopefully that makes sense, Jess?
Yeah.
Alright, 3. What is the area of the region? Okay, that should be pretty easy. The hardest part here is you're probably not going to be able to graph that. You will be able to do the calculator integral, but you won't be able to actually graph it on the calculator. They're very nice to tell you which one's left and which one's right. So remember when you do the integral, how will we perform this integral?
By parts.
No, you're not actually doing the integral.
I'm thinking of the
How
wrong.
do you do it? Because it's like x equals y.
So when you do an integral, in this case, it's something bounded by the right and left. It is the integral of the right minus left. Remember, for x's, we do top minus bottom. So for y's, we talked about last year. We haven't talked about it too much this year, but it's right minus left. So it's either top minus bottom or right minus left. In this case, they tell you which one's left and which one's right. So all you have to do is do the integral from 2y minus y square root y to the 4th plus 1.
But
Probably pull up the questions.
That would help.
how do you do that in your calculator? Because y's.
You change it to x's. Remember, that's a dummy variable inside of an integral.
Oh, okay.
So when you put it in the integral, you can put a y in if you want. There's a y button, but I would just do 2x minus x square root of x to the fourth plus 1. When you're putting a
Okay.
variable into an integral, especially a definite integral, it does not matter what you put. You could put a, b, c, d, any letter you want, because the calculator just recognizes, oh, that's my variable, that's what I plug the number into.
Okay.
Now, one of the harder parts here is to determine the answer to the bounds, because we have to find our bounds as well. Do we have any ideas on how to find our bounds?
Set them equal.
Okay, so setting them equal is correct. How are you going to? Yes, Berrigan, that is correct. Intersect. But the question is, how do you find where they intersect? Because that is not something that is the easiest thing to solve. It's I mean, not the end of the world equation to solve, but you'd have to square both sides.
This one equals 4. And
Tanner's playing Motor GPT in 20.
Okay. He's also one of the only ones talking, so I can't blame him or call him out. But you would have to, if you try to do this by hand, you'd have to end up squaring both sides, and you'd end up with like a y to the sixth and a y squared, et cetera, et cetera. Not a good idea. Instead, what you can do, just like we talked about a second ago, because you're looking for a value, you can plug those in the calculator as x's and solve that.
oh, it's just a calculator problem. Yeah, that's what I did.
Yeah.
I just swapped x's and the y's.
Exactly. That's something that a lot of people are not comfortable with. So the calculator, yep, calculator's on the stream. So what I would do is go in when I put this in. Let's see. Pull this over. When you're plugging things in, it doesn't really matter if you're doing x's or y's. So let's see. I would put in x square root of x to the fourth plus 1. I personally don't like finding intersections. I much prefer to find zeros, so I'm going to subtract 2x to find the zeros. You could graph them both and find their points of intersection, as Berrigan pointed out. I much prefer to do that. I can just update this window over here. I need to change my window to standard, so zoom 6. And the 2 zeros are going to be, or sorry, 3 zeros will be your answer. We are in the first quadrant. So 0 is where it starts right here, and that is the intersection point, I believe. And then it goes to this intersection point right here where it's 0. So 0 to that one, and I'm going to assume we all remember how to find zeros on the calculator. I don't need to show that. If I do, speak up, please. Yeah, and then and then just do your integral from 0 to that number. Apparently ends up being 1.316. And again, if you really wanted to, so second quit. When you do math 9, if you want to do 0 to 1.316, I can put any numbers or letters I want here. So if I really wanted to do it with F's, I could do it with F. And then I could put all my, that just tells me, but the only thing is when I go to my D over here at the end, you do have to do DF. As long as you do that last line, last little part right there where you put DF, then it does not matter what you put as your variable, as long as the differential matches up to that. We just tend to use X's, obviously, for things, or T's. That's what's standard. Any questions? Or are we okay on that one now?
Gucci.
Okay. Number 4. So this would require 2 integrals. So you're going to do one from 0 to, does it tell you where they intersect? You have to figure out where they intersect to calculate the question, yeah. So figure out where those two graphs intersect, which apparently happens to be at 0.5555 and 1.849. Should be pretty easy. It's a calculator question. You guys know how to find intersection points. I'm confident in that part. And just do integral. It's always top curve minus bottom curve. So the reason you have to use two of them is because they change, top and bottom change after they intersect. Does that make sense, hopefully? You guys are being awfully quiet today. It worries me.
Is the answer C?
Yes.
Okay, cool.
Okay, number 5. Ooh, starting volume. Okay, so volume is integral of area. So in this case, we have a rectangle, so area is base times height, and then it tells us the height is 3 times the width. Very easily, the equation they give us there is the width. If you graph that, you'll find that in the first quadrant area, that goes from the x-axis up. So that'll be your width. Each of those is your width. So you just that times 3 times that integral from 0 to 2. So
I forgot how to
graph
do
it.
these.
That's fine. I'm going to graph it and show you because this one's a little more than. Alright, so. Definitely suggest putting this in a fraction as you go to graph it. X minus 2 squared. Oh, really? Stupid calculator. And then 2x plus 1. Don't want to factor that. So let's see. X, Y axis. So if you look at the graph over on the right that you can't see right now, I'll bring the calculator again. Sorry. Alright. So looking at the graph, I can tell that because they told us it is in the first quadrant, bounded by the X and Y axes and that graph, it's going to be this little triangle almost looking thing right there. So for me to have a better visual, I'm going to zoom in on that just to kind of help myself. So I'm going to put my little marker in the middle of that little area, hit enter after I hit zoom. So this is the area right there they're talking about. That's the base of the region. Tanner, why did you just go live?
Why not?
You did. I can see you.
I said why not?
Guess we're in the middle of class. Turn it off.
Okay, 1 second.
So at this point, we had to realize that the base or the width, because it tells us the width is in the x-axis, it's perpendicular to the x-axis. That means it's vertical. So the length from the curve to the x-axis is your width value. So if that is your width and it's a rectangle, that means the height is 3 times that value. So we have an equation for that. That'll be so the area in this case will be 3 times the function. The function times 3 times the function. So it's the integral of 3 f of x times f of x ends up being from 0 to 2. So it ends up with 0 to 2 of 3 f of x squared dx. Because it tells me cross sections are perpendicular to the x-axis, that means I'm going to go vertical because that is perpendicular to the x-axis. And you should get an equation that looks like the one that is on the board in a second. Remember, anytime you want the volume, you do the integral of the area. Does that make sense, Miss Ivy?
I'm just trying to remember it. Kind of. I don't know.
Yeah, it's the part you're, like I said, just remember that it's the integral of area is volume. So if it's a rectangle, rectangle's base times height, or width times height, length times length, whatever you want to call it. And it tells you the height is 3 times the width in the xy plane. So that's where the 3f of x comes from, and the width itself is the f of x.
Okay.
Let's see, number 6. You have the average value function again. Okay, so how do we find average value one more time?
Integral over b minus a.
We have to have that memorized or written down, I guess, at this point. So integral from a to b divided by b minus a. So we have a graph, so how do we find the integral from a to b?
Just look at it.
That's not quite correct.
Squares or rectangles and triangles.
Okay, there you go. So you need to tell me to find the area under the curve. So geometrically, in this case, find the area under the curve. It's no circles, so nice try. So just find the area under that curve by looking at it geometrically. So you have a triangle, a rectangle, and then a trapezoid, and then divide that by 7. In this case, actually, you could just count the area, it looks like, almost. Except for the triangle on the left, you can literally count the area, which is really funny. So you don't have to do much work there. Area ends up being 15. Number 7. That shouldn't have been too hard, I hope. Yeah, number 7 shouldn't have been too bad. Do we have questions on 7?
Yeah. How do you do it?
So split it up using your rules of, or properties, I guess, of integrals. So 3. So you can split it up on the inside because it's addition. You can split that up into multiple integrals. So integral from was, I think, 1 to 4, 3f of x plus 2x. So because I'm adding in the middle, I can split it up into, begin with 2 integrals. The second integral at that point should be easy to solve. It's 1 to 4 of 2x, or you can bring the 2 out front if you really want to. It doesn't really matter how you do it. So I would just leave it as 2x, because then you know it's the antiderivative is x squared, evaluated from 1 to 4. The part over here, however, is a little trickier to, you have 3, 1, 4. I'd bring the 3 out front in this case. So you're doing the integral of f of x dx. The question we have to ask ourselves is, why did they give us the average value is 8? I think it's 8. Yeah, 8. The reason they give us that, as soon as they give me like that kind of information, I'm going to write out what does that mean. That means that the integral from 1 to 4 of f of x dx divided by 4 minus 1 is equal to 8. Well, 4 minus 1 is 3, so that means the integral from 1 to 4 of f of x dx equals 24. So this becomes 3 times 24 plus 15. And there's your answer.
Okay, that makes sense. I just forgot that you can split them up.
Yep, just like derivatives, integrals have the same properties. Basically, they almost are identical as far as that goes. Um, where you can't split up multiplication, but you can split up addition. Subtraction obviously goes the same way. Any other questions about that one?
What was the answer?
That answer was 87.
7.
So
Okay.
D. All right, number 8. Velocity function. Ooh, this is an easy question. What kind of question is this?
Particle motion.
Well, duh. What kind of question is this?
Particle motion.
Duh, but what kind of question is this?
FTC,
How do you know it's FTC, Miss Rudek?
because they give you x equals 3, t equals 0.
FTC.
I think Miss Ivy might be a little behind on the. Maybe she can't hear me. I don't know. But yes, that's Miss.
Hello?
Hello. I think she might be lagging a little bit.
I could not hear you.
Can you hear me now? She might be lagging a little behind. But as Mr. Rick was pointing out, they give you one position and time, and they're asking for a second one, which is most definitely an FTC question. So the answer is, if you look at all of them, you should be able to figure out what all of them mean, hopefully. And figure out how we would find the particle at position t equals 2, and that will be B. The answer is B. Do I need to show how they get the answer to be B? Do we realize what the other answer choices A, C, and D all represent? Because that's also an important question.
Sort of.
Well, isn't c just the derivative at 2?
Which would be what? What question would they have to ask in order for that to be the correct answer?
What is the position at 2?
Nope, that's what they're
Or, I
asking.
mean, acceleration?
There you go, yes. So C is the acceleration at time t equals 2. What about A or D?
D is the total and A is displacement.
What's the difference between those two?
Well, the distance has absolute value bars because it has to include everything.
So A is the difference in where it starts and stops. That's what displacement is. D would be the total distance traveled because it takes all of your area, positive or negative, and makes it positive and then adds it together. So that's the difference. But yes, very good. Any other questions on that one before we move on to 9? Okay, blah, 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 blah. Total distance traveled by particle while moving to the left. Okay, so we know the whole thing has a net of a positive 100. Okay, that's not too bad. So 1875 divided by 2 minus 50. 87, yeah. So the easy way to think about this is if it's, in other words, the positive area is 100 more than the negative area, because it tells me the displacement is 100. The total is 1875. So if you want to make like a system of equations, technically you could, because I know most people don't think the way I do. Um, so easiest way to do it is, I would make A the positive area and B the negative area. So A minus B is 100, and A plus B is the 1875. That's how I would do it. And then solve that system of equations. It becomes very easy to solve. Random question. But yes, Miss Berrigan, I submitted my last assignment last week, so I'm done. As soon as she grades it and gives me my A, I will have my master's degree. Thank you, ma'am. Okay, so the answer to that one would be B. Like I said, pretty straightforward to do. You just have to think about what's the difference between displacement and your total distance and things like that. And if you wanted to, you could assign like A to be the little area, B to be the big area, and then C to be the next big area. Things like that. There's all kinds of different ways you can do it. I just made A the positive area and B the negative area. Okay, number 10. Total distance traveled is typically we could just do the absolute value. If we have a graphing calculator, we don't have a graphing calculator, so you can't do it that way. So you have to break up into two integrals. And basically ask yourself, where is it positive and where is it negative? So hopefully we should know the breaking point of that would be pi over 4, because obviously just by looking at the question, either it's going to be something like C could be the answer, or B or D. I have no clue why they would include A in there. That's dumb. But anyway, so it's got to be B, C, or D. And you just got to figure out where is it positive, where is it negative. And it ends up being D. I mean, that's just knowing your trig functions, knowing where sign is positive, negative, first quadrant, fourth quadrant, etc. So because it's shifted, you do have to be careful. Again, that's the big thing, if you remember all that. Or you could just kind of think about plugging in values. So if you plug in anything in between 0 and pi over 4, you'll get a negative value, which means it's the fourth quadrant, and sign is already negative in the fourth quadrant, so having that extra negative out front actually makes it positive, making the answer choice D. Did everybody follow that, hopefully? I'll take the silence as a yes.
Yes.
11 rate in question. Okay. That's just straight up integral from 0 to 2. That's not a big deal. Remember we talked about this. Anytime you have a rate, if you integrate the rate, you get the amount. So this is straight up R is a rate value. So if I want the amount, the total amount, I just integrate that. So integral from 0 to 2. They want you to do it by hand, so you got to plug in your bounds and stuff like that, but that shouldn't be too bad. Questions on that one? Okay, answer is C. Moving on to 12. Okay, so RFT is a rate again, so it looks like it's just going to be the integral, so the area under the curve of that from 0 to 8. Yeah, so just find the area under the curve, bunch of triangles, trapezoids, and rectangles, etc. So that shouldn't have been too bad, hopefully. So the answer choice there being C. Questions?
Did I mute my mic and then say y'all?
No, you're the only one talking.
Okay. I thought I muted my mic, said something, and then unmuted it.
No. 13. That should be easy. Top curve minus bottom curve. You could do a right minus a left. Right minus left is probably easier. But you could have done top minus bottom as well. You do need to find points of intersection by hand in this case. Which looks to be 2, 0, and 2 for y. Which means 0 and 8 for x. Those are pretty easy to do by hand. Questions on that one? Gonna go with a no. This is the one you got wrong, Tanner.
Yeah.
I'm trying to
I got
trick
all
you.
right except the upper bound.
Did you get it correct and just pick the wrong one?
No, well, I mean, I kind of guessed whether it was tan 1.5 or arc tan 1.5. So I didn't really know.
Yeah, so this is a classic top curve minus bottom curve. If you don't know what your graph of arctan looks like, you kind of got screwed, unfortunately. So for those of you who don't know what your graph of arctan off the top of your head looks like, it'll look like that. And you have your 1.5 up here. So they basically want the area in there from wherever to wherever, wherever they intersect and things like that. And they will intersect at arctan of 1.5. So arctan actually goes above 1.5 because it goes to pi over 2. So it goes a little bit above that. So arctan actually goes above 1.5. So your graph technically should look like that. So that's the region R that they're looking for. It's kind of what I have shaded on the board when you see it in a second. So find points of intersection. Obviously 0 is the first. What's not point of intersection is where it starts. And the point of intersection is where arctan of x equals, or crosses that line, and it tells you the value of x is 1.5. So the y value is 1.5. That means it's arctan of 1.5. Or I'm completely wrong and nobody's paying attention.
Question are we still on 14?
Yeah. Nobody's caught my mistake so far, which highly leads me to believe that nobody's paying attention to what I'm talking about.
I don't even understand what's written on the board.
Yeah, I'm paying
Written on
attention,
the
but I just don't understand the graph you drew.
Yeah, I did it wrong on purpose to see who's paying attention.
I understand
Oh.
the graph, but I don't see what's wrong with it. I mean, you didn't do before 0, but I'm sure that's not what's wrong.
Nobody realizes what's wrong with that graph?
It's not the graph of tangent.
Oh no, that's the graph of arctan. That graph is correct.
Oh.
Yeah.
Oh. It's x equals 1.5, not y equals 1.5.
Thank you. Yes, I did that on
Okay.
purpose to see who would be paying attention. So you have
Say
1.5.
that.
Yes. So
Oh yeah, it does.
there
Oh
is
well,
your
that's why
region.
it's arctan of 1.5. Son of a bitch.
Yeah. So there's a couple different ways you can do it. They obviously do their derivative or their integral in terms of y. If you do your integral in terms of y, that means you have to do right minus left. They try to trick people and make it the answer choice A. A is wrong because those bounds 0 to 1.5 are x values. You have to do a y integral. So you have to have y bounds. This point is obviously 0, 0. That's easy. This point is 1.5 comma arctan of 1.5. So if you're doing y values, because that's how they have the integral set up, your integral has to be right minus left. So right curve is obviously 1.5 minus. This curve, you have to be careful. It has to be solved for y. So in other words, I say x equals. They gave you the function y is equal to arctan of x, which means x is equal to tangent of y. So it's minus tangent of y dy, integral from 0 to arctan of 1.5. That is how you do that problem. And that is how they get answer choice C. So your bounds have to be y bounds, your x is everything because they made it that way. Now, is that the only way to do the problem? Obviously not. You could have done x's, been done with the problem. They're testing, do you understand the whole right minus left thing and stuff like that. Yeah. Sometimes you are required to do right minus left. This is not one of those cases, but you are required every now and then. So you need to make sure you understand that whole idea there. Let's see, 15. That's, again, an easy one. Two different integrals. You have to find where they intersect, which is actually given to you, actually, so you don't have to find that. So integral from 0 to 1 plus integral from 1 to 2. That's a straightforward question. 16 is also a straightforward question. Um, 17. I guess, again, this is cross-sectional area, so we do the integral of the area function, so it's a square, so the area function is just integral of the length squared, side squared, whatever, and if you graph it, you realize that 5 minus 5/3 x is, make sure, yeah, so it's a triangle, so the length of the square will be the 5 minus 5/3 x in that case. So in case you don't see that, you have a graph that looks something like that, and then your squares are made by, if I just kind of cut the dotted lines. So each one of those would create a square, obviously of different lengths or side lengths. Integral function, remember, is always integral of area. Our area is s squared, and over here we know that one of these values is s, so s is equal to f of x minus 0. So it's just f of x, that's the integral of f of x squared dx from wherever to wherever, 0 to whatever. Does that make sense, hopefully?
For number 17, that's what you were doing?
Mm-hmm.
Okay. And why'd you square it?
Because it's a square. And what's the area of a square?
Oh, okay. Side times side.
Mm-hmm.
Hmm.
Any other questions on that one? Okay, we'll do the last one real quick before ending. So this one has the general same idea, except for your side length will be very different. So the only thing that's going to change is that. So which one was on top? Curve. So here when you have this general shape, those distances there will be your S. So here S will be equal to, do they label them? I'm going to call the top one f of x and the bottom one g of x. So the side will just be f of x minus g of x. That's the side length that's going to be there. So that I just substitute that in for my s just like we did last time, except for it's just a more complicated function. So that's f of x minus g of x squared. Oop, forgot my dx. Got a binding marker. Oh, I steal from class today. Does that make sense?
Yeah.
Okay, any other questions? Okay, we'll pick up with section B tomorrow. And I highly suggest you do it, Tanner, because I'm assuming it'll probably be volume. So it's different stuff in this. All right, any questions before we go?
Hey, at 2 o'clock. Honestly.
I will be up there at 1, yes.
Okay.
For those of you that would like to join me. I only invited you guys and Deborah, so.
Bet.
I will be up there at 1 o'clock next. You have a great day as well, Miss Berrigan.
Okay, bye.
Bye.
See ya.
Well, since you're not talking, nobody gets to hear the joke, but you can type the joke all you want, Max.